Okay, here we go again. Let me try this second lesson again. Basically, what I want to talk about this right now on this particular uh, tutorial is the difference between the alkaline and the acidic permanent wave. Okay, we know on the pH scale it goes from, and the pH is potential hydrogen, and it goes from 1 or 0, 1 all the way to 14. In the center there it is 7, which is neutral. Below 7 we have the acidic side. Above 7 we have the alkaline side. We already covered that information. You know that. It's a wrap. You got that. You know, you can pass that question on the test. But just a little bit more specifics on the different ingredients or the different contents in the alkaline wave and the acidic wave. We know what each reducing agent does to the hair, but we want to find out what the active reducing agent is in each of the alkaline and the acidic wave. Now, we find that in permanent wave, the reducing agent is an addition of hydrogen. Okay, we read earlier, or we talked about earlier, where it would either be an addition of hydrogen or a removal of oxygen. In permanent waving, the reducing agent is an addition of hydrogen, which in turn breaks down the disulfide bonds in there, which break down the strongest bond, the least amount but the strongest, and then you have the polypeptide chains are able to reform and then to curl and is reformed by the adding of oxidation. Real quick review on that. But now, real briefly, the difference between the alkaline perm and the acidic perm. The reaction for alkaline, we know that alkaline softens and swells. Key, main specific, the reducing agent in the alkaline perm is ammonia thioglycate. Okay, that's the reducing agent in alkaline perm. All right. You know, the alkaline perm goes past 7 on up, and most alkaline perm starts at 9.0 to 9.6 on the pH scale. Another name for alkaline perm, your book will tell you, is called cold wave. Alkaline wave is the same thing as a cold wave because it processes with room temperature. Okay, it doesn't need any additional heat source, and we'll talk about the endothermic and the exothermic waves later on in the chapter, but this one processes by room temperature. Moving on to the alkaline side, the main reducing agent and the acid side, the main reducing agent in the acid perm is the glycerin monothioglycate. Okay, glycerin monothioglycate is the main reducing agent in the acid. Okay, now there's something called a true acid. Now the pH level in acids are low pHs. Okay, but there is a true acid perm, which is about let's see, what was that? It's about 4.5, between 4.5 pH and 7.0. Okay, on the pH scale. That's what they call a true acid, because we know the pH of hair is between 4.5 and 5.5, and somewhere in there 5.0. So specifically, the difference between the alkaline and the acidic are the reducing agents. One is up the scale. On the alkaline side, 9.0 to 9.6, which is the ammonia thioglycate for the alkaline, and then down the scale, low pH for the acid. The reducing agent is the glycerin monothioglycate. Okay, that's in your book can be found on pages, let's see, 573. And then you go, and when you want to look at that chart there on 573, where it talks about acid and alkaline as well, up the scale, down the scale, the increase of acid and the increase of alkaline in each of the params. Now, in some of the true acid param, there are other ingredients. There are other ingredients, but the main reducing agent, remember, the main reducing agent, alkaline, is the ammonia thioglycate. There are other agents, but the main reducing agent in the acidic param is the glycerin monothioglycate. We'll get back with you later on the next one, and we'll see you then.